So hello everyone. So welcome to another video. So today we'll discuss the hydrology question of CUET exam. So we'll start from 2020. So our first question is about an absolute impermeable rock formation which is neither porous nor permeable. So there are different strata. You can say sedimentary strata or igneous strata. They are defined on the basis of their hydrological property, that is porosity and permeability. So according to the porosity and permeable characteristic, we have these four types of hydrological property of rock, what we called aquiclude, aquifuse, aquifer, aquitard. So it is very important. So always remember, aquifer, it is porous and permeable. Then your aquitard, it is semi-porous and semi-permeable. Semi-porous and semi-permeable. Then aquiclude, it is porous but non-permeable. So you can take the example of clay, shale. Those are highly porous but non-permeable. The cause of non-permeability is in that type of rock strata or that type of rock, they doesn't have interconnected pore spaces. Then we have aquifuse, which is non-porous and non-permeable. So any crystalline rock like igneous, they are non-porous and non-permeable unless until they have some fracture within them. So these are four important characteristic or hydrological characteristic on the basis of porosity and permeability. One is aquifer, which is porous and permeable. You can take the example of sandstone, which is a very good aquifer. Then aquifuse, first remember aquifer, that is porous and permeable. Then your aquitard, it is semi-porous and semi-permeable. Then aquiclude, it is porous, non-permeable. Then aquifuse, it is non-porous and non-permeable. So here we have given impermeable rock formation which is neither porous nor permeable. That means it will be aquifuse, which is neither porous nor permeable. So answer will be aquifuse. Then a subsurface water between the land surface and the saturated zone is called as. So the vertical distribution of groundwater, it is divided broadly into two regions. This is your water table. This is called a zone of saturation. So the water or the region below the water table is called a zone of saturation because all the pore spaces in that zone is completely filled. Then above the water table to the ground surface, they are called as zone of radiation. Where the pore spaces are partially filled. So this also called as ferritic zone, or the water available in this zone are ferritic water. Then zone of aeration, where the water is partially filled, those water is called as your Bhadoj water. Bhadoj water. And this is called ferritic water. So it is given subsurface water, that means water present below the surface. Between the land surface and saturated zone, it will be a zone of aeration, and water is called as a Bhadoj water. So answer will be D, Bhadoj water. Then we have magmatic water, juvenile water. These are water that produce during magmatic crystallization or during magmatic reaction, during dehydration reaction. Those are called as magmatic or juvenile water. Then connate water, that water that trapped within pore spaces of sediments or sedimentary strata, that called as your connate water. So answer will be Bhadoj water. Next, your traditional water harvesting structure in Rajasthan are known as. So generally we use different method of artificial recharge, you can say, where there is scanty groundwater region, you can say, where the groundwater level is very low, or there is not much availability of groundwater, where rainfall is less, or the region is a rocky terrain where water percolation is less, there is more surface runoff. So in that case we use different method. So there is a traditional method in Rajasthan where they use tonkas, these underground well to store water, then these water can reach as the groundwater, or it is a method of, you can say, ki they harvest the rainwater, they store the rainwater by this method. Just they dig a well in the subsurface region and they collect the rainwater. So answer will be tonkas. Then tube wells, these are generally we use in different region to pump out water. There is tube wells. Then katas, these are, you can say, small percolation, small check dams that used to store water to recharge the groundwater. Then percolation tank is also a similar type of tank, but that not used in Rajasthan. So in Rajasthan they use katas. Next question, when a groundwater body is separated from the main groundwater by a relative impermeable stratum of small extent is called as. So when a groundwater body is separated from the main groundwater by a relatively impermeable stratum of small extent is called as. Suppose this is a subsurface region. So the water that trapped between two impermeable formation, these are impermeable formation, they are called as confined aquifer. They are called as confined aquifer, which is sandwiched between two impermeable formation. Then there is unconfined aquifer, which is just below the land surface, which does not, you can say, sandwich between two layers, which is directly under atmospheric pressure. There is called as unconfined aquifer. Then in some region you will find these clay beds or impermeable strata within the zone of aeration, because this will be our water table. This region I have discussed, this is your zone of aeration. In some regions you will find a small extent of impermeable strata which can store water, because this is impermeable, water cannot pass through these strata. So water will, you can say, accumulate over these regions. So these are not a true water table or true saturated zone. This is called as your porched aquifer water table. It is called as your porched aquifer water table. So these are your you can say separated from the main groundwater by a relatively impermeable formation. So it is called as your porched aquifer. But the main aquifer is below here. So one is unconfined aquifer, one is confined aquifer. So any well that dug to the confined aquifer are called as your artesian well. It is called as your artesian well. Any well that dug into the confined aquifer is called artesian well. Any well that dug into the unconfined aquifer, it is called as a water table well. It is called as a water table well. So we have two types of artesian well. One is flowing artesian well, one is non-flowing artesian well. One is flowing artesian well, one is non-flowing artesian well. Because this confined aquifer, it is sandwiched between two layers. So when you dug a well, then water automatically rise to a particular level. That level is called as your potentiometric surface or piezometric surface. It is called as your potentiometric surface or piezometric surface. Sometimes the potentiometric surface is above the ground level or above the land surface. So if you dug a well, water will automatically flow to the surface. So these are called as flowing artesian well. And in some region the piezometry surface is below the surface, below the land surface. So water can rise up to this level, it cannot reach to the surface. Those are called as non-flowing artesian well. So any well dug into the confined aquifer is called as your artesian well. Any well dug into the any well dug into the unconfined aquifer is called as water table well. So artesian well is of two types. One is flowing artesian well, one is non-flowing artesian well. So the answer will be here first water table, and I think you understand about confined and unconfined aquifer and what are the different wells that are associated with confined and unconfined aquifer. Next, same question we have discussed: saturated but poorly permeable stratum that restrict movement of groundwater. It is saturated means all the pore spaces are completely filled, means it is you can say porous, and poorly permeable stratum that restrict movement of groundwater. That restrict movement of groundwater means that it is non-permeable. So it will be your acute fluid, porous but non-permeable. Acute semi-porous, semi-permeable, aquifers your non-porous, non-permeable, aquifer porous, permeable. So next we have a table match question. There are different type of water and the definition is given here. So you have to just you have to know the exact match or correct match, then you remember the definition. Okay. So first is your hygroscopic water. So these are water that found around fine soil, fine grain soil particle. So these are thin film of moisture around fine grain soil particle. Those are called as your hygroscopic water. Or you can say these are moisture around soil, that is called as your hygroscopic water. This is not available for use. Then gravitational water, that water that drains under the influence of gravity. So there are two types of hydrological property we have studied. Then one is your specific yield, one is specific retention. So the specific yield is a amount of water that drain from a rock by the influence of gravity. So that water is called as your gravitational water. Then capillary water, these are rings of water around coarse grain held by surface tension. So water that rise because of your capillary force and around the pore spaces, and they held by surface tension, they are called as capillary. They are called as capillary water. Then intergranular water held within grains, that is called as intergranular water. Sorry, it is intragranular water. Intra means which is within grains. It is not in between grains. Okay, in between is intergranular. It is intragranular means that water present within grains. So let's see what will be our answer. Hygroscopic water. C. So A is third. There is only one option having A is third. Then B is 1, C is second, D is fourth. So option A will be correct. So let's come to another question. That is your two statement is given here. Groundwater flows from regions of lower head hydraulic head to regions of higher hydraulic head. So always remember, groundwater flows always towards decreasing hydraulic head. That means it always flow from higher hydraulic head to lower hydraulic head. Means suppose we have a region which has a height, suppose 20 meter above sea level, another is height 10 meter from sea level. So like this you can say, then water will flow to this direction, to the lower hydraulic head. So hydraulic head, it is decreased in the direction of the flow. This statement is incorrect. Then given line joining points of equal hydrological head are called equipotential line. It is correct. So the line joining equal hydraulic head are called equipotential line. And remember, along the equipotential line there will be no flow of water because they are all present in same height. And remember, the flow lines, the groundwater flow lines is always perpendicular to the equipotential line. The groundwater flow line is always perpendicular to the your equipotential line. Suppose let's see this. We suppose we have equipotential line like this. So this is suppose 20, this is 10, this is 5, this is 0. Then if these are equipotential line, then groundwater will flow in this direction. So the flow line is always perpendicular to the equipotential line. So let's see what will be the answer. Statement 1 is false. Statement 2 is true. So option D. Then which one of the following factors does not have control on flooding? So flooding occur because of higher rainfall in the upper reaches of the river, and there are other causes also. Then rainfall intensity and duration. If there will be more rainfall and more the rainfall for more time, then more water will come, so that can overflow from the river valley. So it will be correct. Topography. So topography also play a major role during flooding, because in the region where there is steeper slope, the water cannot return there, so it will move down downstream. So where there is you can say lesser your gradient, then water will remain for larger time, so they can swell or can overflow the valley. So topography also same, that affects the flooding or control the flooding. Similar topography is also related to channel gradient. So all these three will have a direct effect to the your flooding condition. But evaporation, so evaporation it is not much rapid, so that it will overcome the you can say amount of water that is supplied by these conditions. So that's why evaporation has a very little effect that reduce the water level. So that's why this does not control the flooding. So this will be our answer, that is evaporation. So next question, which of the following grain size the Stokes law is not applicable? Stokes law is applicable for very finer grain sediments. So that should be less than 0.1 mm, 0.1 mm, because if you there is a condition where RE should be less than 1 for Stokes law. RE means Reynolds number, it should be less than 1 for Stokes law. If you put 0.2 mm of grain size, then RE will be greater than, Reynolds number will be greater than 1. So remember, grain size less than 0.1 mm will be applicable for Stokes law. Greater than 0.1 mm, it is not applicable for Stokes law. That's why Stokes law is not applicable for sand size grain. That is not applicable for sand size grain. So Stokes law, it is used to determine the your settling velocity of the grain. So answer will be D. The next question, if a particular maximum or annual discharge of a river has recurrence interval of 10 years, it means the chances of a flood of this magnitude or greater will occur. So the occurrence or the probability you can calculate by 1 by t, that is years or time, is 1 by 10. It will be 0.1 fraction. So 0.1 fraction, or in percentage you can calculate 0.1 into 100, that is 10%. So particular maximum annual discharge of a river has recurrence interval of 10 years. That means every year there is 10% chance for this discharge. So answer will be 10%. So next question, we have acitation and region. The Indo-Gangetic alluvial plains are rich in groundwater resources when compared to Peninsular India. So past our peninsular India, it is considered as a craton. So mostly they consist of crystalline rock like igneous metamorphic rock, which is a non-permeable or non-porous. Only if they are fractured or they have jointed structure, they can recharge the groundwater. So that's why they are in that region the groundwater availability less. But the Indo-Gangetic plain consists of alluvial sediments that derive from the rivers from the Himalaya. So that's why, because of the presence of alluvial plains, they are highly porous and permeable. So they can contain more groundwater. So this statement will be uh, correct. The Indo-Gangetic alluvial plain are rich in groundwater resources when compared to the peninsular India. Then what are the cause? The Indo-Gangetic alluvial plains are characterized by thick alluvium. The thick alluvium always produce more groundwater recharge, and most peninsular rock is composed of hard rocks, or you can take Deccan Trap, you can take Zarwar Craton, Singhbhum Craton, Bastar Craton, or a cratonic region. So they are less porous and permeable. So that's why the availability of groundwater will be less in that region. So the region is also correct. So assertion and region are correct. So both A and R true, and R is the correct explanation of A. So option A. Next question, in general, which of the following has the highest total porosity? So porosity, obviously, you'll find more porous rock in case of sedimentary rock. Always remember, any rock that is crystalline, having interlocking texture, they doesn't have more porosity. So among these, anhydrite, it is a precipitated mineral which is crystalline, so it has very low porosity. Then shale, we know it's sedimentary rock, it is highly porous but impermeable, it is an aquiclude. Similarly, basalt and granite are igneous rock, they are crystalline. Unless ki basalt is vesicular, they have some porous, and unless granite is jointed, it has some porous. So, among these options, shale is the highest total porosity, and anhydrite is the least, you can say. So, answer will be shale. Which one of the following is the most widely used geophysical method of groundwater exploration? So for groundwater exploration, we basically use electrical resistivity method. So in electrical resistivity method, we supply current to the subsurface region. So we measure the resistivity. So when these current they flow through the subsurface region, they doesn't flow like ions. They flow like, you can say, flow in a electrolytic solution. So for the flow of this current, they require water and porous formation. So in the region where you'll get very less resistivity, that region will be more porous and contain more water. So that direct indicate the presence of groundwater. So that's why electrical resistivity method is used to determine groundwater in the subsurface region. The radioactive method is basically used to explore the your radioactive minerals, in the uranium, thorium, like that. Then magnetic method for magnetic mineral, gravity method for any metallic mineral, because all the metals are more denser and more, they have more mass and more gravity. So answer will be electrical resistivity method. Then which one of the following is not an example of a recording type rain gauge? So there are different type of instrument used to determine the rainfall amount. So among these, the Simon's rain gauge, it only collect the rainwater. So after you collecting the rainwater, you have to use a graduated cylinder to measure the amount of rainfall. In all other setting, they can collect and measure. So only these Simon's rain gauge. So you have it only collect the rainwater, then you have to manually measure it. So answer will be Simon's rain gauge. Then in Darcy equation, so Darcy equation states Q equal to KIA, where hydraulic gradient is represented by. So Q, it is your discharge, amount of discharge. K is your hydraulic conductivity, and I is your hydraulic gradient, which is H1 minus H2 by L. This is called hydraulic gradient. And A, it is the cross-sectional area of the aquifer. So Q has a unit meter cube per day. There is a unit of Q discharge. K, it is meter per day. The unit of K. I, it doesn't have any unit. It is dimensionless quantity. And A is area meter square. So answer will be your I. The next question, the rainwater falling on the land surface that drains across the land into a stream. Across the land, anything that flow, that called as your overland flow. That flow over the land and they recharge or they feed any stream channel. So the rainwater falling on the land surface that drains across the land into the stream channel is called as your overland flow. Then groundwater flow below the subsurface region. Then base flow, it is also a groundwater flow that fed the stream, but the stream is here the stream is fed by the overland water or surface runoff. Base flow when the stream is fed by underground water. Similarly, the subsurface flow is similar to the groundwater flow. So your answer will be overland, because only this condition indicates a runoff, surface runoff. All other conditions shows the flow is below the surface. So answer will be overland flow. So arrange the following geological materials in order to increasing capillary rise in them. So capillary rise, that depends upon the diameter of the pore space. The lesser the diameter, the more the capillary rise. So you have to consider among these which one has less, which has the smallest pore space in terms of diameter. So you have here silt, it is the smallest one. Then we have fine sand, then coarse sand, then gravel. We have to arrange in increasing order. So fine gravel, which have least capillary rise, so it will be D. Then coarse sand, then fine sand, then silt. Silt is the highest, so it is in increasing order. D, C, A, B. So A will be the correct option. So we come to two statement. One statement one is specific retention of a geological material is that percentage of volume of water which drained by gravity. So you have two hydrological property. One is called specific retention. One is called specific yield. One is specific retention. One is specific yield. So volume of water retained by total volume into 100. Then volume of water yield by total volume into 100. That means the volume of water yield means the volume of water that drained by the influence of gravity, that is volume of yield. And after the removal by gravity, the water remain or retain is called as the volume of retention. So specific retention of a geological water, that the percentage of water of volume which is drained by gravity, is incorrect, because it is not specific retention, it is specific yield. It is specific yield. Then next statement, water holding capacity of soil is called field capacity. So this statement is not completely correct, but water holding capacity of soil after it is drained by gravity, that is called as field capacity. But can say it is correct. So statement 1 is incorrect, statement 2 is correct. Then remember, specific retention plus specific yield is your porosity. Specific retention plus specific yield is equal to porosity. Next, which is a good reservoir rock? So reservoir rocks are porous and permeable. So among these, you can say the sandstone. It is a reservoir rock. They give reserve petroleum. Then granite, it is fractured rock, cannot have that much of porosity and permeability. Shale is porous but permeable, sorry, impermeable, so it can act as a cap rock. Schist, it is metamorphic rock, doesn't have that much of porosity. So always a reservoir rock is a you can say sedimentary rock, mostly sandstone and limestone. And shale, clay, those are cap rock. When the water table slope towards the stream, in context of stream aquifer interaction, the stream can be classified as. So there are two type of condition. One is effluent, one is influent. If the water table slope towards the stream, that means the water table will feed the stream. One is your effluent, one is your influent. So influent, it feeds the groundwater. And effluent, it fed by the groundwater. Suppose you have a reservoir here. This is water table. This is water table. See, if the water table you can say slope towards or within the reservoir, then this condition is called as your effluent. And this is called as your influent. So as the water table is below the reservoir, so groundwater will be fed by the reservoir, by the water capacity of the reservoir will lessen. And if it is within the water table, then water table will feed the reservoir. So here it is given the water table slope towards the stream means it fed the stream, so that will be effluent stream. Effluent stream. So answer will be effluent. Next question, artificial recharge to groundwater. What are the correct method or use that to recharge the groundwater artificially? Augments the groundwater reserve. So we use different method to increase the volume of groundwater by you can take by borehole or by specific condition where we provide water to the groundwater reserve. Mostly nowadays we do borehole up to 100 feet, then we recharge the groundwater. So if you do artificial recharge to the groundwater, then the volume of the groundwater will increase. Augment means Sojiki, there is an increase of size of groundwater. So then if we do artificial recharge, that may prevent seawater intrusion to the fresh water. So why seawater intrusion happens? Because in coastal region, if you pump out more water, then the seawater will flow to the regions where the water is loses. That produce a cone of depression. Then water from the surrounding region will move to that region. So if it is in coastal region, then seawater will also enter into the freshwater region where the water will become brackish type. So if you recharge the groundwater, then or if you do less pumping or more recharge of groundwater in coastal region, then it will not produce that cone of depression, so where there will be no intrusion, seawater intrusion. So if you do artificial recharge groundwater, there will be less seawater intrusion. Then may help arresting the declining groundwater tables. Obviously, if you recharge groundwater, then it will limit the declining groundwater table levels. It will increase the level of groundwater. Then may help in reducing or stopping any significant land subsidence. So if you pump out water from the subsurface region, then pore space will become emptier. So if the pore space will become emptier because of pressure, gradually the pore space, the rock will compacted, the pore space will reduce and the volume will decrease. So if the volume will decrease, then there might be subsidence. If the water will be present, there will be no shrinkage of the you can say there will be no shrinkage of the pore spaces. So that also help in reducing, stopping any significant landslide. So all the options are correct when we'll do artificial recharge. So answer will be A, B, C, D. An unconfined aquifer has porosity. We have just given this formula: specific yield plus specific retention is equal to porosity. So specific yield is given 0.1, specific retention we have to calculate, it is given 0.4, so it will be 0.3. The answer will be 0.3. Then comes to porosity of an aquifer is referred to as. Then comes to porosity of an aquifer is referred to as. So porosity, we define it is the volume of pore spaces present within a rock. So porosity always represent percentage volume of voids or volume of pore space by total volume into 100. So let's see the option: ratio of volume of the total voids to volume of the aquifer. So it is correct. Ratio of volume of aquifer to the volume of voids. It is incorrect. Ratio of volume of connected pores to volume of aquifer. So this is actually specific yield, or you can say there is a specific yield or effective porosity. It is called as effective porosity. Ratio of the volume of the aquifer to the volume of connected pore space. So our answer will be A, and this, remember, it is specific yield or effective porosity. Porosity is actually two types. One is effective, one is absolute. All the pore spaces, they collectively called as absolute porosity. Only interconnected pore spaces are called as effective porosity. That's why effective porosity controls the permeability. Next, global hydrological cycle can be represented as a system containing. So hydrological cycle that includes the atmosphere, the surface, then the groundwater, all these regions, the water cycles because of different processes. So atmospheric water system, surface water system, and subsurface water system, these are the components of the hydrological cycle. So it will be A, B, and D. Then seismic liquefaction system, it is liquefaction of sediments during seismic activity, during tectonic activity. So it does not belongs to hydrological cycle. Next, which of the following the correct about the common source of groundwater pollution and or contamination? So maximum gases from gas plants. So from gas plant, the toxic gases that remove, or the toxic gas they release, they directly release to the atmosphere. So it doesn't affect the groundwater. Indirectly they can affect, but directly they affect the atmosphere. So it will be incorrect. Then leakage from waste disposal sites such as landfills. So any waste material, that is toxic material, that leakage from waste disposal site, they can enter into the groundwater region. So they can affect the groundwater, pollute the groundwater. So it will be correct. Intrusion of salt water into the coastal aquifer, that also pollute the groundwater. Then leakage from storage tank and pipe, any chemicals or toxic chemicals that can leakage from pipes or from sewage, they can also affect the groundwater. So these three B, C, D, they affect the groundwater pollution. So answer will be D, B, C, D. So next comes to another table match question where different terms are given and their definition or their meaning is given. So first is infiltration. So infiltration, so it is a process where your movement of water into the earth, that is called your infiltration. Water infiltrated below the surface. Then transpiration, it is movement of water through vegetation. The transpiration process by which water move through vegetation. Then runoff, movement of water over the surface, that is surface runoff is like. Then evaporation, movement of the water into the atmosphere. So let's see, infiltration, A is second. So there is one option, A is second, B is fourth, C is 1 and D is third. Option B will be correct. So these are terms, so you just remember. Then an absolute impermeable rock formation through which there is no possibility of storage or movement of water. Actually, it is aquifers. So these questions are repeating again and again. So you have to remember these four: aquitad, aquiclude, aquifer, and aquifers. So aquitad is semi-porous, semi-permeable; aquiclude, porous, non-permeable; aquifer, porous, permeable; aquifers, non-porous, non-permeable. Then types of water that exist in the micropores of soil particle that we have discussed, it is called capillary water that present within the pore spaces of the soil particle or micropores of the soil particle. Then gravitational water, already discussed, that water that drain with the help of gravity. Then hygroscopic water, there are thin film or around the soil particle or moisture around the soil particle. Then peculiar water, it is similar to correct water that within the sedimentary strata. Sorry, pellicular water. So next question, the standard unit of permeability in CJ system. So permeability is the ability to flow water through the rock or through the sediments. So CJ unit is your Darcy, given by Henry Darcy. Then Siemens, it is electrical conductance. Then Centistoke, it is kinematic viscosity. Then Henry, it is electric inductance. Darcy is your permeability, Siemens electric conductance, Centistoke is your kinematic viscosity, Henry is your electric inductance. So let's come to next question, that is your Deccan trap, the groundwater mostly occurs in. So see, Deccan trap consists of igneous rock. So in igneous rock, the groundwater the mostly occurs in along these you can say fracture zones, vesicles, weathered zone, interturbance bed, all can contain groundwater. So it is given if it is a MSQ question, then all can be correct because fracture zone can contain groundwater, vesicles can contain groundwater, weathered zone because weather that when basically Deccan trap consists of basalt, so basalt is more prone to weathering. So when it's weathered, water can infiltrate into the basalt region because weathering loosens the rock. Then interturbine beds, these are sedimentary beds, so they can also contain water if they expose to the surface because interturbine beds, they sandwich between two basaltic layer. If the basalt is more fractured or vesicular, then water can percolate. If it is crystalline, then water cannot enter to the interturbine beds. So among these, the best option will be weathered zone because fracture we'll say they can basalt contain columnar joint. So, but that is not found everywhere. Then vesicles, the vesicles that produce can filled up by secondary mineral by when why we'll call them as amygdaloidal structure. So when they will fill, they cannot yield groundwater. Then intertopant beds that sandwich between two your this is one lava flow, this is lava flow in between sedimentary, this is your intertopant beds. So because of this lava flow, water cannot percolate here unless it is exposed somewhere in the surface like this. So most option appropriate option will be weathered zones. So this is all about your hydrology question from 2020 to 25. So in the next video we'll cover another topic. So try to watch this video till the end, and if you like it, then can share it and can comment on the video. Thank you.